Hi everyone, my name is Geeta. I am a senior solutions architect at Elastic. Today I thought I'd spend some time discussing about the eBPF solutions that can be used in observability space and also for endpoint security, how you can potentially use BPF based code and also solution that can solve some problems in the endpoint security space. Let's get started. So if you're aware of how monitoring works and how in the observability space, there are three main pillars. One is APM, logs, and metrics. So these three will essentially help you to create a modern observability solution, right? But the way we have traditionally done instrumentation is pretty invasive. If you want adding instrumentation manually, APM will insert itself into the code and it gets recompiled. This type of deployment can result in all sorts of issues that can bring down production environments. And eBPF can provide a method to get observability data you need with instrumentation at all. And as a result, far better safety can be acquired. And when you write eBPF code to run in the kernel, it is first compiled to the BPF bytecode using Clang, and then the bytecode is verified to make sure it's safe to execute. These strict verifications guarantee that machine code will not intentionally or accidentally compromise the Linux kernels, and that the BPF probe will execute a bounded number of instructions every time it is triggered. And that's how you can use eBPF under the hood to create a better observability solution. And using BPF solution, right, you can solve some problems using this BPF compiler collection tools called as BCC tools. There's a link I'll give you at the end of this presentation for you to check out. That's a good place to start when you look under the hood of these BCC tools. What these tools are doing is that they abstract away a lot of code needed to bootstrap eBPF and all these programs into the kernel, and they make them easily accessible via Python code. I'll show you a bit of a code in the next slide, but so some of the problems that you can solve with using these BCC tools in conjunction with eBPF are debugging disk I/O latencies. You can also track the slow file operations on Linux kernels with the help of BPF. And then you can summarize all these XFS operation latency with the help of BPF and BCC tooling. And then you can also track kernel functions to find an issue with request and reduce the disk writes slowdowns. Now, eBPF does have some limitations. It cannot safely modify data. So the virtual machine that runs the eBPF code has read-only access to the variables in the code. And this is really important because otherwise this could result in all sorts of unexpected problems. You can't really add tags or tracing IDs to code dynamically in a practical way with eBPF as you can with an APM-based solution. So technically it is possible, but it involves patching memory. It's also unsafe and potentially has higher overheads. So therefore, APM agents and OpenTelemetry, they still have a good place in the world today until those issues are resolved. Given that we need to add tracing information, logs, and metrics data to our code in the current day. So there's this bit where there's when you have tracing that's being done under the hood and metrics that are being collected, you will have to generate a context and tie all of that data together. This could be shifted over to eBPF. And eBPF-based agents for its performance benefits and for all the speed of summarization, and because it has access to much more of the underlying systems with the help of this universal profiling and whatnot. At the same time, you can use an eBPF-based agent is what I'm trying to tell. At the same time, this eBPF could be used to gather deeper and more interesting information, security, network data, security data, and then data using about Kubernetes and other systems and services traditionally beyond the reach of APM. Yeah, that's a little bit about how you are going to use this. And then there's this bit of a Python code that you're seeing there. What's happening there is that you are basically printing a hello world program for each child process that is created from a terminal, because it has a hook for this sys underscore clone, um, as you can see in man pages. And if you plonk this code into a Python file, you should be able to run it, and you'll see that in another terminal you'll start writing commands to see this hello world appear in each time you launch a process. So there are some interesting things going on in this program. First thing is, you're defining a BPF program using a simple text. This is written in C, and then this is a shortcut for kernel dynamic tracing via kprobes. If the C function begins with kprobe, the rest is treated as a kernel function, as you probably know, to hook into, in this case, the sysclone function. And there's a simple kernel facility of printf in order to use a common trace pipelining function. And there's this trace print. It's a BCC routine that reads trace pipe and then prints out the output. So this is what is essentially happening there in this Python program that is eBPF based. It's worth checking out the BCC tools in the repository I'm going to give. You'll have all the ways to help with so many problems that you'll experience, especially the ones that with traditional tools that have not been able to solve for you yet. And you will see an integration of these tools coming up in your favorite observability solutions soon. And then moving on to the endpoint security. So the way endpoint security you can do is in Linux kernels or any kernels, you can leverage eBPF for two use cases. First thing is host isolation. The other one is event sourcing, with all the code pertaining to all this. You either use it for event sourcing, which can leverage BPF to source all the variety of security related events on Linux machine. And it does all this by hooking into a variety of kprobes and trace points and ftrace hooks with BPF programs. If you are aware of that, you can leverage those hooks that exist already and leverage BPF to source the events for you, and then analyze those events of this for endpoint security. And then for host isolation, you can perform also similar cases for host isolation. And then you should be able to achieve the level of security that you desire for these Linux machines with the help of these kprobes and trace points. That's what I wanted to cover, and thank you so much for this opportunity and for your time today. Bye.